All right. So this was also one of an interesting physics question, which most of the students found it difficult. Some of them were able to completely do it, and some of them were stuck in between, and some of them didn't know how to apply the frictional force part in this question. So this was an MCQ question uploaded in the channel, the community, but you will not get this lengthy MCQ question for your O-level exam. But this is to understand how you can tackle these kind of questions. So first of all, the question tells an object of mass 5 kilogram is initially at rest on a rough horizontal surface. So let's sketch that part down. We have a surface and we have an object on the surface. We have an object on the surface. And the mass of the object is 5 kilogram. Okay, and they tell that this surface is rough. Why do they tell that the surface is rough? Is it an unwanted data? No. If a surface is rough, always remember there would be frictional force. Frictional force acting in between the surface and the object. If they tell it's a smooth surface, then there is no frictional force. Correct. So then they tell a horizontal force of 25 Newton is applied to it. A horizontal force of, let me mark the forces using a different color. A horizontal force of 25 Newton is applied to it. If the frictional force acting against the motion is 5 Newton. Now we know that the object moves to this direction and there's a frictional force acting against the motion, which is 5 Newton. So we can put a frictional force here, which acts against the motion, which is 5 Newton. So they're asking, what is the velocity of the object after traveling a distance of 8 meters? First of all, let's find the resultant force. Let's stop thinking about anything else and let's find the resultant force. Okay, resultant force is going to be 25 Newton to the right plus 5 Newton to the left, which is going to be 20 Newton to the right. This is the resultant force. After the resultant force, we apply the F equals ma equation, which is Newton's second law. F equals ma equation on the 5 kilogram object. Okay, so F, what's the force? It moves with the resultant force of 20 Newton. So the force is 20 Newton here. The mass is 5 kilogram. Now, we have a hint here. We have only one variable which is remaining, which is the acceleration. So from this step, we can find the acceleration of the object as 4ms minus 2. If you double line this is not the answer because we are not asking you the acceleration. We are asking you the velocity. We are asking you the velocity of the object. So after traveling a distance of 8 meters. So now you have the acceleration. How do you find the velocity after it travels 8 meters? So that's kind of a, this is the part which most of the students had asked us in WhatsApp, like how do I continue after this part? So you have two methods. One is the normal O-level method, okay? Normal O-level method. And another one is a pro method. Let me first show the normal O-level method. So first of all, you know work done. Work done is equals to force into distance. Okay. Work done is an energy. What is our force? We have a resultant force of 20 Newton. So our force is 20 Newton. And in the question they tell us the distance is 8 meters. So we get 160 Newton meter here, which is the work done of the object. Okay. After you find the work done, since the object is in motion, it was in motion, you take kinetic energy, which is half mv square. So you know that the energy is 160 and the mass of the object is 5 kilogram. And here you go, you have the velocity variable here. So you know that if you solve this, you will be getting the answer for the velocity. So you continue this by 160, I can move 2 to the other side and 5 to the other side as well, which is going to be v squared. V squared is going to be 160 over 5 into 2, which is 64. V is going to be 8 ms minus 1. This is the answer. If this is the steps you have to follow if you're using the normal O-level method. But in case if you are some kind of a pro, and if you knew the equation of motion, which is, let me just write it down. You have four equations of motions. Like, let me write down the one which is relevant to this, which is v squared equals u squared plus 2as. So in which v is the velocity, final velocity, u is the initial velocity, a is acceleration, and s is displacement. If you're asking me to list other four equations, there are v equals u plus at, s equals half u plus vt, s equals ut plus half at squared. If you want more, I think it's available in our short note, but this method is not in your levels. Only use it if it's for an MCQ. This question was for an MCQ. I uploaded this in the community as an MCQ. So if it was an MCQ, you can use this because it makes the work easy. Look at how many steps we are going to skip. Okay, so v squared, we just need a v squared, and you get stuck here. If you're a pro, you get stuck here. Initial velocity, you think, oh, what is the initial velocity? You go to the question. They haven't given the initial velocity name. Here, on the beginning of the data, they have told initially the object is at rest. So if it's at rest, the initial velocity is obviously going to be 0. So it's 0 plus 2, acceleration is 4, displacement, which is the distance, is 8. So v squared equals 64. V is equals 8 ms minus 1. So you can get the answer in a snap by using the equation of motion if you need. But no worries, just a couple of steps extra and an extra logic using the normal O-level method. So practice these kind of questions which may be tested for your paper. See you all in another question. Bye bye.